Welcome to Biology My Passion. I am Soumya Harikrishna. We have been learning the chapter Work and Energy. In the second part, I did a few questions related to work. In this, we will learn questions related to basically energy and power. So let's start. Is energy a scalar or vector quantity? We know that energy is a scalar quantity because it does not have direction, only magnitude, like work. Work is also scalar. The amount of energy possessed by a body is equivalent to. We know that the energy means the ability to do work. So amount of work done will be equal to the amount of energy. So the answer would be the third option, the amount of work. If 20 joule of work is done in moving a body from one place to another, energy of the body is. If 20 joule of work is done, obviously the energy will also be 20 joule because energy and work are same. So here option B is the correct answer. If the velocity of a moving body becomes 1/5 the kinetic energy of the body, kinetic energy is equal to half mv square. But here m is a constant. So kinetic energy is directly proportional to square of velocity. Here it is decreasing 1 by 5. So square of 1 by 5 is 1 by 25. So if velocity is decreasing to 1 by 5 fifth, then the kinetic energy will decrease 25 times. If both mass and the velocity of a body are double, kinetic energy increases. We know when mass is increased, double, kinetic energy also becomes double because they are proportional. But if velocity is increased, double, then the kinetic energy becomes 4 times because it is square we have to take. So total how many times? 4 into 2, 8 times increase in the kinetic energy. Calculate kinetic energy of a body of mass 2 kg. So moving with a velocity of 0.1 meter per second. Here just we have to substitute. Kinetic energy is half mv square. Mass given 2 kilogram. It is in SI unit. Velocity given 0.1 meter per second. So if you substitute these values in the equation, kinetic energy is equal to 1 by 2 into mass 2 into velocity 0.1 the whole square. 2 and 2 we can cancel. So 0.1 whole square, what will you get? 0.01 joule. That is the unit of kinetic energy. A bullet of mass 50 gram is traveling at 400 meter per second. What is the kinetic energy of the bullet? Here we know that the kinetic energy, the equation we are familiar, half mv square. Here mass is given 50 gram, but remember gram is not an SI unit, so we have to convert it into the SI unit kilogram. So divide it by 1000. So 50 by 1000 it is 0.05 kilogram. And it is traveling at a velocity of 400 meter per second. 400 meter per second. So kinetic energy of the bullet is equal to 1 by 2 into 0.05 into 400. So you will get 1 by 2 into 0.05 into 400 into 400. If you cancel out with 2, it's 200. So if you multiply all this, you will get 4000 joules. So kinetic energy is 4000 joules. How fast should a man of 50 kilogram run so that his kinetic energy be 625? So we know mass is equal to 50 kg, it's an SI unit, and his kinetic energy is also given, it should be 625 joule. So what are we supposed to find out? We have to find his velocity. So velocity is equal to half mv square is equal to, if you substitute, if you find v square, ke into 2 upon m. Ke is 625 already given into 2 upon mass is 50 kg. So if you cancel out 25 times 625. So v square we got 25. Therefore v square root of 25, what is it? 5 meter per second. Always write the unit. A man drops a 10 kg rock from the top of a 5 meter ladder. What is the speed just before it hits the ground? What is its kinetic energy when it reaches the ground? Mass is given 10 kilogram. We know that when something is dropped from top, The value is the energy it possesses is potential energy. So height is also given 5 meters. Kinetic energy is equal to the potential energy, because once it starts dropping, the potential energy eventually gets converted into kinetic energy. So ultimately both will be equal. So PE we know it is mgh. M we know it is 10. G is taken as 10 and H is equal to 5 meters. So if you calculate, we get potential energy is 500 joules. So obviously that is equal to kinetic energy. So kinetic energy is also 500 joules. So if you substitute that in our kinetic energy equation, 500 joules is equal to half mv square, half into 10 into v square. So v square, how will you find out? 500 into 2 upon 10. So if you cancel out, you will get v square is equal to 100. So therefore what is v? V is the square root of 100. We get 10 meter per second. And we know that potential energy is getting converted into kinetic energy. So just before touching the ground, it has zero potential energy, but the total potential energy becomes kinetic energy. How is kinetic energy of a moving car affected if a mass is tripled and velocity becomes one-fourth? Remember, kinetic energy is directly proportional to mass. So, if mass is tripled, kinetic energy also becomes 3 times. But how will you solve that? Take the first case as half mv square. In the second kinetic energy, or the second condition, it becomes 3m. We make it half into 3 mv square. Now we find the ratio between the second case and the first case, half 3 mv square upon half mv square. Half mv square is common factor. So Ke2, or the second kinetic energy, is equal to 3 times that of the first kinetic energy. So kinetic energy also tripled. The same way we know, if velocity becomes one-fourth, it is 1 by 4 the whole square, that is 1 by 16 times decrease will be there. But still, how to solve it? First case is taken as half mv square. Second case, half into mass remains same, but velocity becomes 1 by 4 the whole square. So if you solve second kinetic energy to first kinetic energy ratio, if you find half into m into 1 by 16 upon 1 by 16 mv square upon half mv square. Again, half mv square is the common factor. So kinetic energy in the second case is first case divided by 16 times. That means 16 times decrease is observed in the kinetic energy. Car is moving with a uniform velocity of 15 meter per second. So velocity is given, it is v is 15 meter per second. What is the kinetic energy of a boy of mass 40 kg? So mass is in SI unit, sitting in the car. So his kinetic energy will be equal to that of the car because he is inside the car. So half mv square, we can directly substitute and find the value, half into 40 into 15 into 15. So here, if you cancel out 20, then 15 into 15 is 225 into 20, 1500 joules. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joules. What will be the kinetic energy when its velocity is doubled? What will be its kinetic energy when its velocity is tripled? So you know that velocity is equal to 5 meter per second in this case, and kinetic energy is 25 joule, it's given. We want to find out when the velocity is doubled, what is the kinetic energy? So we know that when velocity is doubled, obviously the kinetic energy is going to be 4 times, but we can consider showing the calculation. First case is taken as half mv square, second case is half m 2v square. So 2v the whole square. So it is ratio, if you find out between the second case and first case, you will get second case, it is 4 times that of the first case. So the kinetic energy increased 4 times. So initial kinetic energy was 25. So 4 times increase means now it is 100 joules. What will be its kinetic energy when its velocity is tripled? So in this case it is 3 times. So tripled means it will become how many times? 9 into 25 times. That is, calculation you can show like how we showed above. So the calculation will give us the answer 225 joule. Find the velocity of a body of mass 0.1 kg having a kinetic energy of 20 joules. So velocity we have to find out. Mass given 0.1 kilogram. Kinetic energy is also given 20 joules. So if you substitute the value, K is equal to half mv square. V square we can find out by substituting the given values. So V square is equal to 20 into 2 upon 0.1. So V square is equal to 400. Therefore, V is equal to square root of 400. We get 20 meter per second. What is the work to be done to increase the velocity of a car from 36 km per hour to 72 km per hour if the mass of the car is 1000 kg? Initial velocity is equal to 36 km per hour. So in order to convert it into meter per second, you have to multiply by 5 by 18. So you will get 10 meter per second as the initial velocity. The initial kinetic energy we can find out from this half mv square. Mass is not going to change, so it is half into 1000 into 10 square. So half into 1000 into 10 square is 100. So we get 50,000 joules. Now the velocity is increasing from 36 km per hour to 72 km per hour. That means final velocity becomes 72 km per hour. That is 72 into 5 by 18. We get 20 meter per second. So final kinetic energy would be half into, again mass is the same 1000 into 20 into 20. So again if you simplify it, 20 can be divided by 2, we get 10, then you multiply, you get 2 lakh joule is the final kinetic energy. That's obvious when velocity increase double, here actually double increase is happening. So the kinetic energy should obviously increase 4 times. So now here what is the work done? The change in energy is work done we can calculate. So second kinetic energy 2 lakh joules minus 50,000 joules. So 1.5 lakhs you will get, or 150,000 joules is the work done. If you like my videos, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.